Welcome to class E. We're going to talk about, well, actually share my screen with you. We're going to talk about the midpoint formula and the distance formula, and I should zoom out just a bit. Also, just as so everyone knows, I will also post the file with the class notes. So if it's not easy to read what I'm writing because of the video quality, I don't know why it's not uploading HD, you can always look at the class notes and try and see that or whatever. So let's get started with the midpoint formula. And let's start with an example, then we'll talk about the general formula, then we'll go back to more examples. So let's look at this example. Let's say we want to find the midpoint of the points. What do we got here? -1, 6. Let's write this up here too. So midpoint of -1, 6 and 7, 2. So over 7 up 2. So I want to find the midpoint there. I should grab a ruler. Got one. Yeah. So we can try to see where it is visually. Right? If I actually look at this line segment, right, don't connect those. The midpoint looks like it's maybe right about there. And what's interesting is one way to think about the midpoint of these 2 points is really just averaging each of the x coordinates and each of the y coordinates. So if you take the average of -1 and 7, -1 plus 7 is 6, divided by 2 is 3. 3 is 4 away from 7, 3 is 4 away from -1. So 3 is the middle x value there, or it's the x value that's halfway between -1 and +7. In a similar way, the y coordinate, well, if I take the average of 6 and 2, 6 plus 2 is 8. 8 divided by 2 is going to be 4. And that y coordinate is 4, right? 1, 2, 3, 4. And that's totally halfway between 2 and 6, right? It's 2 more than 2. It's 2 less than 6. So this point here, 3, 4, is the midpoint of the point -1, 6 and 7, 2. And literally the way we calculate the midpoint is just by taking the average of the x values and the average of the y values. So when I think of the midpoint, I really think of it as an average. So to make this a little more explicit, or formulaic, I should say, let's say we want to find in general the midpoint. I should say because there's only one midpoint of any 2 points. The midpoint of x1, y1 and x2, y2. If I do something similarly graphically, like if I have like this point here, and let's make it easy to draw, I'm going to go like over 1, 2, 3, 4, 5, 6, and then 4. Sure, why not? So let's call this x1, y1, and this x2, y2. The midpoint of those 2 points is going to be right there. And it's exactly written as the average of the x's, so x1 plus x2 divided by 2, and the average of the y's, y1 plus y2 divided by 2. And sometimes people label it as capital M. I don't usually do that, but fine. I'm doing it here because then you can see, oh yeah, there's capital M. It's just the middle of the x's and the middle of the y's. If you really want to think about it, right, you can kind of draw this out like this, like, oh yeah, from here to here, the distance is 1, 2, 3, 4, 5, 6. So halfway is going to be 1, 2, 3. Yeah. And from here to here, the distance is 1, 2, 3, 4, and halfway is 1, 2. So yeah, there's your midpoint. It's pretty easy to calculate the midpoint. Sometimes it gets a little bit less nice if the values aren't like nice integers. But we'll do a few examples and then we'll move on to this formula. So sorry, I'm a little cluttered over here. All right, so let's see here. So we don't need to graph these to find them. It's nice to graph them, but really it's easier not to. So let's lose the graph paper for a second. Where's my other paper? Sorry, I've got all the paper all over the place. So let's say we want to find the following midpoints. The midpoint, I didn't label things. Oh well, such is life. I'll label the pages later. So I want to find the midpoint of the following pairs of points. And I encourage you, if you have the opportunity, to pause the video and try it yourself first before I do it. So let's look at example 1. let's say we have the points, what did I write down here? 2, 3, and 5, 7. So really all I'm going to do is say that the midpoint is, and I really just like to write out the formula. So I'm going to do 2 plus 5 divided by 2, right? The x coordinates add together, an average divided by 2, and the y coordinates add together, 3 plus 7 divided by 2. That's going to give me 7 halves and 10 halves. 7 halves, you could leave as 7 halves. 10 halves, you should simplify as 5. So I'm going to write this either as 7 halves comma 5, or if you prefer a decimal, 3.5 comma 5. Either way is fine there. Let me see if I can, okay, that looks all right. Let's do a couple more just to see a few things that might come up. Let's look at this next example I have, which is, gosh, why is it so hard for me to see my own writing? Sure. Let's say example 2. We have the points -6 and -1 and 3 comma 5. That is a 3, believe it or not. Again, it's the same process. So we're just going to take the x coordinates, -6 plus 3, and add them together, divide by 2. The y coordinates, it doesn't actually matter which order you add in. You can do -1 plus 5 or 5 plus -1. Whatever you're adding, it doesn't really matter. So 5 plus -1, if I want to write it that way. Well, -6 plus 3 is 3 minus 6, which is -3. So -3 over 2. And 5 plus -1 is 5 minus 1, which is 4 over 2. Again, you can leave -3 halves as a fraction. So you can say you got -3 halves, comma 4 divided by 2 is 2. Or once again, if you prefer a decimal, -1.5 comma 2. If the points you're starting with both have integer coordinates, meaning whole numbers or negative whole numbers, your averages will either be whole numbers or fractions with the 2 as the denominator, or decimals with a 0.5. That's kind of the only thing that can happen. That is a little bit different if you start having, say, like coordinates that have decimals themselves. For example, let's say I want to find the average of the points 4.2 comma -3.1 and -1.8 comma -1.5. Yeah, it's kind of gross. Still the same process. So the midpoint, I guess I could write here, I should have written like the midpoint is equal to, here the midpoint, I like writing words personally, is same process. 4.2 plus -1.8. You can also write, sorry, divided by 2, just 4.2 minus 1.8, but I really want to emphasize the fact that we are adding these two things together and then dividing by 2, comma -3.1 plus -1.5 divided by 2. Once again here, right, you could have written -3.1 minus 1.5, but just remember that you are adding things together. So here, when you add a negative, you're really just subtracting. So 4.2 minus 1.8 is going to be 2.4. So 2.4 divided by 2. And -3.1 minus 1.5 is going to be more negative. It's going to be -4.6 divided by 2. 24 divided by 2 is 12. So 2.4 divided by 2 is 1.2. -4.6, well, -46 divided by 2 is 23. Sorry, -23. -4.6 divided by 2 is -2.3. I would leave these as decimals since they started off as decimals. If you really want, you can convert them to fractions like 12 over 10 and -23 over 10, and reduce this one as 6 over 5. But really, that's unnecessary. You should leave it kind of in the format we started with. That's probably enough examples. I mean, I feel like it's pretty, oh, sorry, this was example 3, not example 2. I feel like it's a very straightforward process. You're just adding two numbers together and dividing by 2. Just to be careful about the signs. A negative plus a negative is more negative. A negative plus a positive is going to kind of go one way or the other. Like here, like this positive plus this negative became less positive or less negative, depending on which way you're like it's less positive than 4.2. It's certainly less negative than -1.8 because it's a positive. But yeah. All right, let's look at the other thing, which is the distance formula. And again, we'll start off with an example. We'll start off with kind of a very cherry-picked example because, well, it's nice to have nice examples sometimes. So let's see here. I'm going to start off with the example of I want to find the distance between the point 1, comma 2. So let's draw the right one here. and the point 4, 6. 4, 6, yeah, 4, 6. So over to 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6. Cool, there we go. So I want to find the distance between these 2 points. In other words, I want to find the length of this line segment here. Well, what I'm going to do is I'm going to draw a triangle. So use a different, fine, sorry. So I'm going to drop, I'm going to kind of like draw the line over here and draw this line over here. And I would point out that this height of this triangle is just the difference in this y value and this y value. So this length here is 6 minus 2, which is 4. This length here is this x value, 4, minus this x value, 1. 4 minus 1, that's going to be 3. Yeah, I mean, right, from this point here to this point here, I've just gone 1, 2, 3 over, so the length is 3. From here to here, I've gone exactly 4 up, so the length is 4. But from here to here, we're not going straight up or straight left or right, so we can't just say, oh, the distance is however much. So what we're going to do is we're going to use the Pythagorean theorem. We're going to say that this side of the triangle and this side of the triangle are the legs, right, the 2 smaller sides, and this hypotenuse, which is the distance, or the length of the hypotenuse, is the distance between the 2 points. We can calculate that using the Pythagorean theorem. So I'm going to call this distance, say, capital D. It's pretty standard. And then I'm going to say, well, I know that this length squared, 3 squared, plus this length squared, 4 squared, equals that length squared, which is D squared. And then I can actually find the length here. It's going to be, I picked these nice numbers, so it will come out nice. It's not always going to come out nice. 9 plus 16 is D squared. 25 is D squared. So D is equal to the square root of 25. And so D is equal to 5. I do want to point out that the way we found these numbers here, right, this number 3 and this number 4 was, 3 was the difference in the x's, 4 minus 1, and 4 was the difference in the y's, 6 minus 2. So just to kind of backtrack a little bit, I could have started off by saying, oh, the distance squared is really the difference in the x's, 4 minus 1 squared, and plus the difference in the y's, 6 minus 2 squared. And if I square root both sides, I can have kind of a more formulaic way of writing this. The distance is the square root of 4 minus 1 squared plus 6 minus 2 squared, which is just the same thing over here, right? The distance is going to be the square root of 3 squared plus 4 squared. And then that's going to equal the square root of 25. And that's exactly going to give us the distance is equal to 5. So this kind of sets up how the formula actually works. So let's actually write out the formula on the next kind of graph to kind of see how it looks. So I'm just going to pick random ass points here. Sorry, okay, I said a naughty word. Oh well, such is life. Sometimes people swear, it does happen. So let's say this point is x1 comma y1. This point here is x2 comma y2. And I want to find the distance between these 2 points. So I'm looking for the length of this line segment. I'm going to call it D. And I'm going to drop perpendicular down to here, perpendicular over to here. And not that you need to know what this point is, but I will tell you this point is, if I've gone from here to here, I haven't moved up or down, so the y coordinate is the same as this y coordinate. And from here to here, I haven't moved left or right, so this x coordinate here is the same as that x coordinate there. So this length here is the difference in the x's. This is x2 minus x1. And this length here is the difference in the y's. It's y2 minus y1. So if I want to find the formula here, well, I'm going to say that the distance squared, I'm kind of writing the hypotenuse, the Pythagorean theorem backwards, right? Usually it's like this squared plus this squared equals that squared. I'm writing it this squared equals that squared plus that squared, which is totally fine. The distance squared is x2 minus x1 squared plus y2 minus y1 squared. And if I square root both sides, now be careful here. It's not that the distance is equal to x2 minus x1 plus y2 minus y1. When you take the square root of one side, if we take the square root of the entire other side, x2 minus x1 squared plus y2 minus y1 squared. And that's your formula for the distance between 2 points. You certainly can draw a picture like this when you do it, but it is not necessary whatsoever. Let's do a few examples and then we'll call it a day. So let's go back to, we don't need the graph paper anymore. So let's say, we have two examples. And so some of these are going to come out to be not nice numbers. That's okay. And when I say not nice, I mean not integers. They're going to be irrational. They're going to be square roots that we can't simplify any further. That's totally fine. So for example, I want to find the distance, let's see, between the following pairs of points. And really, I'm just going to throw them into this formula. And I will make one comment about how, well, I'll make a comment in a minute. So let's look at example 1. Let's say the pairs of points are 0, 2, and 5, 4. So I'm going to say that the distance between these 2 points is equal to the square root of, and then it's going to be the difference in the x values squared. So the difference in the x's is 5 minus 0 squared. The difference of the y's is 4 minus 2. So plus, we need that plus sign there, 4 minus 2 quantity squared. And then we should simplify as much as we're capable of. So that's going to equal the square root of, well, 5 minus 0 is 5. 4 minus 2 is 2. I still have to square both of those. So that's going to be the square root of 5 squared, which is 25, plus 2 squared, which is 4. 25 plus 4 is 29. And the square root of 29 isn't a nice square number. It's not 25. It's not 26. So we just leave it as is. If you're really curious, you can get a calculator. I've got a calculator somewhere around here. It's my backpack over here. 1 second. I could use my computer, I know, but I like using actual calculator. So if we really want to know, we can say, well, the square root of 29 is about 5.39. You don't need to tell me that at all. The rightest answer for the distance is the square root of 29. There's no better way of saying it other than it's the square root of 29. The other thing I wanted to mention here is that it actually doesn't matter which order you subtract them in. You could do these ones minus these ones, but you could also do those ones minus those ones. So just to point out, we could have done this as the distance is equal to the square root of 0 minus 5 squared plus 2 minus 4 squared, which ends up equaling the square root of, well, 0 minus 5 is negative 5 squared, and 2 minus 4 is negative 2 squared. The negative 5 squared means, right, just to point it out on the side here, negative 5 squared really means negative 5 times negative 5. And the negative times a negative is a positive. That's going to be positive 25. So here we get the same thing. We get the square root of 25 plus negative 2 squared is positive 4. And that's still the square root of 29. So it doesn't matter which order you subtract things in, you're still going to get the right answer either way, as long as the other work is correct. Let's look at a couple more examples. Let's say I want to find the distance between, what have I got here? I have negative 3 comma negative 2 and negative 7 comma, that seems kind of boring, James. Let's say negative 8. All right, so tossing things into the formula. All things being equal, I usually think of these ones as the x1, sorry, the x2, y2, and these ones the x1, y1. So I'm usually doing these ones minus those ones just because that's the way my brain usually works. But it doesn't actually matter. I wrote that way too long. Oh well. So let's see, I'm going to do the difference in the x's, negative 8 minus negative 3 squared. If you really like, you can also label them to make it easier for you. You can say, oh, this is my x1 comma y1. This is my x2 comma y2, if that helps you. Not required at all, just might be helpful. So negative 8 minus negative 3 squared plus, oops, I made a mistake. I did negative 8 minus negative 3. That's y minus x. That is not going to work. I need to do x minus x. So let's try that again. I might run out. Let's get a new piece of paper because I'm going to run out of room here. So I was doing the distance between the 2 points. Let me remind myself what I had here. I had negative 3 comma negative 2 and negative 7 comma negative 8. Let's try this one more time. It's the square root of the difference in the x's squared. So I'm going to do negative 7 minus negative 3 squared plus the difference in the y squared, which is negative 8 minus negative 2 squared. Okay. You can simplify this however much you like. Negative 7 plus 3 could be one step of simplification. Negative 8 plus 2 could be another step of simplification. And then negative 7 plus 3 is negative 4. squared. Negative 8 plus 2 is negative 6 squared. So then I'm really ignoring the negative there. I know 4 squared is 16. So I know that negative 4 squared is negative 4 times negative 4, which is still positive 16. Similarly, 6 squared is 36. So negative 6 quantity squared is 36. And this is equal to the square root of 52, because 36 plus 16 is 52. I'm perfectly okay with you leaving this as an unsimplified square root. Technically, since 52 has a square factor, right? 4 is a factor of 52. We could simplify this as the square root of 4 times 13, and then the square root of 4 times the square root of 13, which is equal to 2 times the square root of 13. In my book, both of these answers are perfectly acceptable, but I will tell you in the future, someone might expect you to simplify this down to this because this is considered the more simplified form. It's just the way it is. Let's look at 2-ish, maybe 2 more examples. So let's say we have example 3. Say I want to find the distance between, so distance between, what do we got here? 3, 2 and -2, -1. So you should try this one on your own first before I do it. But I would say if I'm doing this, I'm going to typically do the positive ones minus the negative ones if I have that choice. If they're both negative, it doesn't really matter. I mean, it doesn't actually matter at all. I feel like it's easier for me to calculate 3 minus -2 squared plus 2 minus -1 quantity squared. But if you, so I'm going to get 3 plus 2, which is 5 squared, and 2 plus 1, which is 3 squared. Right? Because minus a minus makes it a plus. And then you have the square root of 25 plus 9, which is the square root of 34. And that's as simple as that gets. 34 doesn't have any square factors. Its factors is 2 times 17. So we're just stuck with that. Something worth knowing, it's good to know that the square root of 52 is a little bit bigger than 7 because it's bigger than the square root of 49. Likewise, square root of 34 is just a little bit smaller than 6 because it's smaller than the square root of 36. It's good to have that kind of number sense that, oh yeah, square root of 34 is definitely less than the square root of 36, which is 6. And the square root of 52 is bigger than the square root of 49, which is 7. I like to think about those kind of things. Let's do one more example where the numbers are just a little bit more heinous, and then that'll be it. So let's actually go back to that decimal point I was using before. Let's say, I'm going to switch it up a little bit. Let's say I want to find the distance between, this is where things are going to look a little bit ugly. Maybe this might be a bad idea. We're going to do it anyway. Sometimes bad ideas. I'm gonna make it a little bit less terrible. Let's say I want to find this between. Sure, let's do that. 4.2, 3.1, and I'm going to make things, sure, -1.8, comma, let's go with 2.5. We'll see if I put any of these on the assignment, but I just felt like we talked about decimals, might as well. So distance, this is example 4, is going to be, let's see, the square root of difference in the x's. Doesn't matter which order you subtract. I'm going to do this one minus that one. So 4.2 minus -1.8, and then all that squared plus the difference in the y's. You technically should subtract in the same order. So if you do this one minus this one, you should also do that one minus that one. It doesn't actually matter for the distance formula, but there are other formulas where the consistency matters. So it's good to be consistent across the board. So I'm going to do 3.1 minus 2.5 squared. So here I'm going to get the square root of, let's see, 4.2 plus 1.8. Let's see, 4.2 plus 1.8. 2 plus 8 is 10. Carry the 1. 1 plus 4 plus 1 is 6. That's going to be 6 squared. And then 3.1 minus 2.5. So can carry a 1. 11 minus 5 is 6. 2 minus 2 is 0. So that's going to be the square root of 36 plus 0.6 squared. So you can either do this, you can do this a lot of ways. You could do it this way, 0.6 times 0.6. 6 times 6 is 36. And then you're supposed to have like 2 decimal places because that's how decimals work. If you're not super familiar with that, you can also say 0.6 is 6/10. And so 0.6 squared is 0.6 times 0.6, which is 6/10 times 6/10. And then you multiply 6 times 6 is 36, 10 times 10 is 100, and 36 divided by 100, or 36 hundredths, is exactly 0.36. What I kind of think about is 0.6 is a number that's smaller than 1, and when you multiply something by something that's smaller than 1, it should get smaller. So 0.6 times 0.6 should lead to a number that's less than either one of those. And then this ends up equaling the square root of 36.36, which is definitely not very nice. You try and plug that. I mean, it's going to be just a little bit bigger than 6. If we do it, the square root of 36.36 is, yeah, it's approximately 6.0299. But I would just leave it like this. So I don't know if I'll actually put any of those on the handout for class on Monday, but just so you're aware, that's something that can also happen. Last words I'll say here is, so on Monday, we'll definitely have some midpoint problems. We'll have some distance formula problems. There might still be some Pythagorean theorem problems. Any of the stuff we've already done is fair game. So I might throw a line or two on there. I might throw a parallel line or a perpendicular line on there just to keep the practice up of seeing what we've already done in addition to what we're doing. Yeah, that's all I've got. I hope you all have a lovely weekend. Try to watch this. I don't know, whenever. I mean, if you're hearing this part, you've already watched it. So me saying try to watch it whenever is kind of stupid. So I'll post something in Canvas about when to try and watch it. And yeah, I'll see you on Monday. Looking forward to it. Bye.